when you are curious, you should not hold back. You should just go ahead and take that step. I realized how, if you are helpless, that there is that virtue of trying the very best with what you have. What could have the Balanese Egyptica fruit extract? This was traditional medicine, so scientifically, what does Balanese Egyptica do? What is it that this uncle trusted it could do? When I looked, I was shocked because I saw some changes to the molecular level. We can now even extract them and use them now in the and turn them into medicine.
Welcome to the EAJNS podcast. Today, we will be exploring the intersection between neuroscience, toxicology, and traditional medicine. The study we'll be discussing investigates the effects of Balanese Egyptica plant extract on the prefrontal cortex in MSG-induced neurotoxicity in adult males. This work speaks not only to neuronal injury and recovery, but also to the potential role of plant-based neuroprotective therapeutics in the future. We're delighted to be joined by John, Riak, Kiir, Kuany. Thank you so much for being with us. To begin, we'd love to understand your motivation behind the research. What motivated you to study MSG-induced neurotoxicity in the prefrontal cortex?
Thank you very much. So when I was living in Juba, there was a case of a young guy who just finished his high school, scored some good grades, but was not able to advance to the university. So he stayed at home trying to do this and that as he was waiting for any opportunity to join the university. So along the way, maybe boredom or something else, so they started involving themselves in drugs. And the drug that he quoted was, they started using marijuana so much. And it came a time when they decided to stop it. And when they stopped it, they developed psychosis. And when they developed psychosis, the community and his relatives were so concerned, they started moving him around hospitals. So from this hospital to another one, to this, to that. So one day they were under a tree, just over the other side, and I was at home, I was just looking. And they were just wondering where to take him because they were still waiting for money from abroad to take him to the hospital, and the money was not yet there. So they, as they were sitting around and thinking, one of the uncles of the kid just went and brought a cup. I was to find out later that the cup contained a solution of Balanese Egyptica fruit. So he brought that cup and he gave to the guy, and the guy took it, and they continued to wait for the money to come from abroad. So when I thought about that, I realized how, if you are helpless, that there is that virtue of trying the very best with what you have. So I've been questioning myself since then. What could have the Balanese Egyptica fruit extract been? What could it have done to this guy? Or what is it that this uncle trusted it could do? And I wondered, could it be because Balanese are so widespread in South Sudan that people might think that they are blessings from God? Or could it be that the uncle knew that it has a remedy? So when I came to the University of Nairobi, when I was in first year, I wanted to do BSc anatomy. And I realized that for you to do that, you have to do research. So when I started thinking around research, it was at that time when things to do with high-fat, high-fructose diet was so the current trend that everybody was looking into it. And me and most of my classmates, we wanted to do something neuroscience. So we were restricting ourselves to anything to do with the brain, the spinal cord, or nerves. So when I realized I was spending a lot of time and there was pressure to come up with concepts, I decided to settle with the effects of high-fat, high-fructose diet on the testes. And I went ahead to write a concept which was accepted. I wrote a proposal. But when we were presenting the proposals in a journal meeting of the University of Nairobi, Professor Paul Ochieng Odula asked me one question. He said, you are giving an insult to the testes, and then you are now investigating the effects of that insult. So whether you are using high-fat, high-fructose diet, you are using a diabetic model or anything, is insult not insult? So I told him that I'm going to think about it. And then when I started thinking about it, it gave me some doubts about my study. So I was still advised by my supervisors and other people that I should just modify the study, put into consideration what the professor said, and work on it. But I felt like I should not go further, because I feared I might go further and then I get another question that I cannot answer, and that will be a wastage of time. So one Sunday, I was teaching some first years human anatomy, and then when I was about to leave, I saw that Dr. Mochaka's car was at the parking. So I said, let me pay him a visit. So when I paid him a visit, I expressed to him the doubts that I had. And then I showed him one research that I had seen online. It was by Parfait et al. It was about Balanitis aegyptica. So I started asking him. I gave him the story that I just told you of that young guy in Juba. Could we do something that is related to Parfait, but now exploring not just the effects of MSG, but something to do with mental illnesses or psychosis? So when we were thinking around it until around 8:30 p.m. that day, we decided to try something on the prefrontal cortex. And he was shocked, because the moment we proposed that, there was my face that just shone with surprise that this is something that I should have thought of before. And that's how I went, and I did some research on it, and that's how I decided to do it. Yes, and that was the motivation.
That's a very interesting story, and the fact that it comes from a very personal aspect just makes it better. So was this study for the male rats, was it inspired by concerns around dietary exposure or by previous experimental findings?
I will say previous experimental findings, because when I read around literature, there was no any effects of dietary consumptions of MSG on the human body. And even on those that were done on rats, there was no any notable effect. So the reason we used MSG was we wanted something that could just quickly cause injury to the brain and mimic acute psychosis. And when we read around literature, we found that using 4 milligrams of MSG was high enough for male albino rats. And that is how we did with MSG. But dietary-wise, MSG is safe if taken at dietary levels. It is only when you go to the extreme high levels that are only given experimentally that you can see some effects.
So your study also raises a very important ethnopharmacological question. Why did you specifically choose Balanitis aegyptica for your study?
So the same thing that I already mentioned in the story, Balanitis aegyptica is what was used traditionally for any mental conditions, be it anxiety, mood disorders, or even psychosis. And I decided to use it because I said, now that it was used traditionally, let us see if something can come out scientifically.
So for our listeners who are not neuroscientists or anatomists, why is the prefrontal cortex such an important region to study cognitive function?
So the prefrontal cortex is like, they call it like, if it was to be a house, it is a sitting room of the house. So this is where all the decision making, the personality of a human is housed. And when you think of mental illnesses and psychotic disturbances, psychic disturbances, you have to wonder, does this touch the personality? And if so, the prefrontal cortex must be involved. And it was just curiosity. Yeah? So we asked ourselves, because the prefrontal cortex is the place where the personality of a human being is housed, is the place where there is the short-term memory is processed, it is the place where there is decision making and all that. And many of the conditions we've been reading online usually involve the prefrontal cortex. So we asked ourselves, could acute psychosis also be involving the prefrontal cortex? And that's why we went for the prefrontal cortex.
MSG is something that's consumed worldwide. How much is known about MSG-induced neurotoxicity, and what can we do with that information?
The much that is known about MSG-induced neurotoxicity is only if it is used at experimental amounts, because at dietary amounts it is safe. And I will take us back to so long ago in USA when MSG was used so rampantly that people started to think that it might be having some effects, and there were some effects that were attached to it. But when studies were done and it was examined, they realized that at the normal dietary levels in which it is consumed, it is very safe. Only that if now you go to high amounts that are only achievable experimentally, do you expect some effects. So the neurotoxicity for monosodium glutamate is just experimental, and none has been reported to have come about following dietary consumption.
Yeah. So now let's talk about how your study was structured. Why did you choose adult male albino rats, and how are the experimental groups distributed?
First, I will want to express that that was not deliberate. We wanted to use juvenile rats, those are the young ones, because we thought that, me personally, I thought that the guy in Juba was like a young adult, just 18 to something there, so still a very young youth. So we said we should use young rats, and we went ahead and bought young rats. But now we had not we had not put it in our plan that extraction of Balanitis aegyptica might take some time. And it came out that it took nearly 2 months for it to be freeze-dried. And this made the rats now from being few days old to being 2 months old. And that is why we said, but adults also could develop acute psychosis. So let us just use the adults, and then in the future, we will recommend people to use juvenile rats.
So this Balanitis aegyptica, how did you source them? Where did you source them from? And also the MSG.
So first, when I remembered that story that I just told, I started calling. I didn't know that Balanitis were in Kenya. So I called a colleague in Juba, South Sudan, and asked him, do you remember, it is called Thao in Dinka. Do you remember it? Could you try and help me find the scientific name, because I'm trying to search for it here. And he found it before me and sent it to me. So when I started Googling, I saw things about it. And when I decided to do the study, I just called my young brother who is in Juba, and I told him, I've gone to the department, to the School of Botany, and they have told me that they know Balanites, yes, but Balanites are currently off season in Kenya, so I can source them from my own personal sources. So when he brought the Balanites, I took them to the Department of Botany. They were able to authenticate and recognize that they are the same Balanites, and I can go ahead with the study. So I sourced them from Juba, South Sudan.
That's very interesting. And histology plays a very central role in your study. So which light microscopic techniques did you use to assess the changes in the prefrontal cortex?
I used toluidine blue staining, and I prefer toluidine blue because when I read around it, I saw that when you stain a section with toluidine blue, a brain section, it is going to stain all the cells in that section, and it is also going to stain them differently. So that once you see it staining a particular cell this way or that way, you know that that is a pyramidal cell. When it stains it this way or that way, you know that is an astrocyte. And that's why I went ahead with toluidine blue stain. It is also called a Nisil stain.
In your study, dosage and timing was a very important factor. So how did you decide the dosage and also the exposure, that's the timing of the Balanitis aegyptica and also the MSG?
So this is following what I had been described before. Somebody called Wagas et al. Together with colleagues, Wagas with colleagues, they had come up with a protocol of using Balanitis aegyptica with MSG. And the protocol sound perfect for me, and I just replicated it.
So, for your results, what were the most striking histomorphological results that you achieved?
So in the MSG treated rats, the nuclear apparatus had some noticeable changes. The nuclear envelope particularly was disintegrated, and the nucleoli were very tiny or not there for some cells. Also, the cellular processes, this is the dendrites and the axons, they were so thinned down, and even in some, they appear to be few. And there is a particular structural component of an axon called neurofilaments. So the neurofilaments appear not to be there because they should usually be 3 to 5 in number, and they usually arise from the cell body, that is the soma, and then they converge in the axon. So these ones were not there in the MSG treated group. Going ahead, we usually have a 1 to 2 neuron astrocyte ratio. So for every one neuron, there is at least 2 astrocytes for a normal section of the brain. But for the MSG treated rats, there was gliosis. Gliosis is that the astrocytes were increased in number around the neurons. Finally, there were some occasional aberrant cells. So there were some findings we were not expecting, and we saw only in the MSG treated group. And these were things like there were some cells that appeared to be fused together, and their nuclear membranes seem to have a connection. So fused cells with internuclear connections. Also, there were some cells that appear to have vacuolations in the nucleus, among other aberrant cells. So those were the changes we noticed in the MSG treated group.
Your study suggests several protective mechanisms. Which properties of Balanites aegyptica do you think contribute to these properties?
So there were 2 properties of Balanites aegyptica fruit extract that we hypothesized could be the ones responsible for the neuroprotective effects. One was the antioxidant property of Balanites aegyptica. We saw that Balanites aegyptica fruit extract from literature, it has some flavonoids, phenols that are, among others, that are believed to have antioxidant properties. The other property was that the Balanites aegyptica fruit extract contains some anticholinesterase properties. So these 2 properties, that is the antioxidant and the anticholinesterase properties, they were responsible for the neuroprotective effects of Balanites aegyptica.
If you were given access to more advanced techniques, which ones would you access to make your study better?
If I'm given more advanced techniques, I will go down to the biochemical level of explaining my findings. And I can even go ahead and try and do immunohistochemistry or immunofluorescence. Yes.
If we take a step back and look at the bigger picture, what implications do your findings have on dietary-related neurotoxicity in humans?
So like I had already mentioned before, my study was not out of dietary concerns. And I'll just repeat, like I said, that dietary consumption of MSG is very safe. And the reason I used MSG was I wanted to mimic neurotoxicity, which is usually what comes about from drug abuse. And this one, we were only able to achieve it after administering high levels that are only achievable experimentally. So I'll still say that there are no dietary concerns. It was just a model to get to achieve neurotoxicity in rats.
Yes. Your study also has a very strong traditional medicine angle. How do studies like yours help traditional medicine be accepted more with modern medicine?
That's a very good question. So when I saw this incident that I just talked about, that Balanites aegyptica is being used in traditional medicine to relieve mental disorders, and I also read online some research papers and I saw the same. So I said, if this is the case, what can we now come out with scientifically? So this was traditional medicine, so scientifically, what does Balanites aegyptica do? So, and when I went through the literature, I saw the rest. So I saw that the gap is that I have now to see if there are any histological changes that can explain this use. And that is what I went for.
This study would have been a very personal journey for you. What was the most challenging or surprising part of this whole study?
So to begin with, the most challenging part was to entirely leave my study, the one I wanted to first do, and stick to this one, and also to remain adamant despite being even asked to stop this study and look for other studies, because they thought this was more technical. It was an MSc level study. So I remained adamant. So it was a challenge to believe that if I follow it, something might just come out. And the surprising part of it was that, when you see something is being used traditionally and you become curious and you want to see the scientific basis of it, you usually don't know if there might be something substantial out of it. But when I had finished sectioning my slides and I just put them under the microscope, when I looked, I was shocked because I saw some changes. And this was surprising and relieving to me. So I think that was a surprising bit of it.
If there's one message that anyone should take away from your study, if there's one message that listeners can take away from your study, which would it be?
The one message will be, when you are curious, you should not hold back. You should just go ahead and take that step.
Okay, so the treatment group showed noticeable differences. What were the major differences between the Balanites aegyptica, those treated with Balanites aegyptica, and those with MSG?
So I already talked about what was seen in those that were only treated with MSG, and the ones that were now treated with Balanites aegyptica, we treated them at 3 dosage regimens. So there was 125, 250, and then 500. So the 125 guys didn't have so much to be seen as notable differences. The changes were seen now beginning from 250 and 500. And the changes included the nuclear envelope now being seen, and the nucleolus being seen as prominent in the nuclear envelope. Also, the cellular processes were now evident, not thinned out like the ones we saw in the MSG treated group. And particularly in the 500 milligram group, we were able to see neurofilaments in the axon. And then finally now, the neuron astrocyte ratio was now balanced to the 1 to 2 astrocytes as it should be in the normal group.
Oxidative stress is mentioned repeatedly in your study. How does oxidative stress mediate MSG-induced neurotoxicity, and how does the extract counteract this?
So oxidative stress usually comes about when now there is a certain way that neurons have to be excited. But now when you excite them every now and then, because now there is so much glutamate in the synaptic cleft, you are now going to create what we call excitotoxicity. And any shift in all these is going to also shift the redox balance. So, and when this balance is shifted, there is going to be accumulation of reactive oxygen species. These reactive oxygen species are very dangerous physically to the neurons and to the cells of the prefrontal cortex. But now when you give Balanites aegyptica, which has antioxidant properties because of phenols and other compounds that are active in there, these are going to counteract the oxidative stress. And when they counteract the oxidative stress, this accounts for the changes in the morphology that were observed in the groups that were treated with balanites as opposed to those that were treated with MSG only.
Yeah. So thinking ahead, do you think plant-based therapies like Balanites aegyptica can be used for future therapeutics?
I think so. 2 ways. First, I think that they can continue to be used traditionally. Now that we know that that has some anatomical basis, they can continue to be used traditionally. Also, this when we take a step further and find out the active components of balanites to the molecular level, we can now even extract them and use them now in the and turn them into medicine. So it can be for both the traditional medicine and the conventional care.
Is there anything else that was very impactful to you during this study that you'd like to share?
The other thing that I can just add is that when I was doing this research, it was not only scientific, it was also personal. There was also some personal development to it, the interactions, the communications, frequently associating with colleagues. I got some help from colleagues also, and trying to source the money for the research. So all these ones, they have some personal, they have some value apart from the scientific evidence that we are growing. There is also, you grow as an individual when you do such studies.
Thank you so much for this very insightful session. To our listeners, the article is published in Volume 4, Issue 3. You can access the article at EAJNS.org. Be sure to read it and continue the conversation with us online. Until next time, thank you.